So I'm going to talk about liberating the value of data, and since everybody else has been talking about data, it's kind of inevitable that I will touch on some of the points they've raised, although I hope that I'll put a slightly different spin on them. I want to begin with the sort of general observation that what's going on is being driven by advances in computer technology and hardware technology, if you like. And I think there are three aspects to this. The aspect which I think is most important, but which is not usually stressed by people, is the ability to capture data at an unprecedented rate. Now, this might be from automatic measuring instruments like intensive care units in a hospital, like satellite photographs of crops. You don't have to go out with a clipboard or measure it with a ruler by hand. The data are just automatically accruing. It might be travel cards as people travel through London or some other big city, or credit cards. Again, you don't have to measure all the stuff, it just goes into your database automatically. So automatic data capture. The data might accrue as a side effect of other exercises. Jonathan talked about administrative data. So supermarket transactions are an example of that. Again, the data is just automatically accumulating. Hospital admissions, school tests, tax records, I've written these down as examples. You don't have to make the effort to collect it, it's just happening. We talk about data shadows and data exhausts of the kind of data you leave in these automatic collection procedures as you go about your everyday life. So that's the first sort of aspect of the revolution, which is leading to what we're talking about today, the fact that data are being captured automatically at an unprecedented rate. The second one is something which we're all familiar with because this is one of the things that's emphasized, and this is the ability to store vast masses of data. Computer storage is so cheap now that it's basically, it's a negligible cost. And then the third one, which is also mentioned, is the ability to manipulate, process and analyze these vast quantities of data in highly sophisticated ways which are advancing all the time, to squeeze illumination from the data, to extract meaning from the data. And I want to say a bit about the various classes of tools which are used to do that, because this is what's in some sense driving the revolution, and then a little about different kinds of data. So various classes of tools. One of the key kinds of tools which is associated with big data, the phrase big data and the phrase data science, are what are called data-driven tools. These are statistical tools which are not based on any underlying theory or understanding of what's going on, but are merely based on looking at correlations and relationships in data. You observe that two things are related, and it's based on a very large amount of data, so you infer that that's likely to happen in the future. And of course, organizations like supermarkets or credit cards build models based on these data-driven kinds of approaches. They won't tell you why a particular variable is predictive for why someone will default on a loan, for instance, but all they know is that the data show that this particular variable is related, so they put it in their model. So data-driven, not theory-driven. Then there are predictive tools. These tools are not mutually exclusive classes, they overlap. Predictive tools for things like medical diagnosis, has this person got disease A or B? Crime recidivism prediction, crime prevention and so on, is this person likely to commit a crime? So predictive tools, and there's been a huge amount of work on those sorts of areas. Again, they are primarily data-driven models over the last 40 odd years. What I did my PhD in, and that was more than 40 years ago, dare I say. And then, of course, those lead on to more elaborate methods, which you all have heard about, certainly things like deep learning, artificial intelligence, and text and image processing, and so on. And then, talking of text and image processing, there are tools to cope with what are called unstructured data or heterogeneous data, different kinds of data, data which doesn't come in nicely formatted rectangular tables of cases by variables, but come in all sorts of different kinds of structures. They might be records of varying lengths, they might be images, signals, text, all sorts of things. And then Jonathan touched on this, and I'm going to say a little bit more about it in a moment. Tools to combine data of different types from different sources. So in the health domain, there's a lot of work going on combining numerical data about patients with epidemiological data with clinical trial reports with medical images and all sorts of things, combining data of different sorts. Talking of images leads me on to visualization, which Alan spoke about at length, very eloquently, very persuasively about length. One thing, I would say that visualization has two purposes. You talked about communication. A picture's worth 1,000 words, and I think you argued that very convincingly. But I think there's another use, which is discovery. You will plot the data this way and that way, and you will see a relationship or structure in it, which would be impossible to see from the sorts of tables you put. But I think that's a slightly different use from communication. And then we come back to linkage, combining data from different sources, perhaps of the same type. So until recently, I chaired something called the Administrative Data Research Network, which took data from all, in principle, it took data from all UK government departments and combined the data sets to potentially yield very powerful insights. And of course, you can take that further. So for example, we could, in principle, take supermarket food purchase records. We didn't do this at the ADRN, but you could do this. We hope to be able to do this sort of thing in the future. You could take supermarket food purchase records and combine that with health records, which would be a very powerful epidemiological tool telling you, and again, automatic data capture, telling you how diet and people's expenditure on food influences health. I was going to also refer to another kind of tool called multi-party computation. This was to answer a question Jonathan asked. I'm going to have to send him an email now to tell him the answer to his question. But his question was, how do you get data from different countries to produce some sort of aggregate statistic when it's there are legal barriers on divulging data even within a country, let alone between countries. Multi-party computation is a very clever and relatively recently developed kind of tool for this. And I'm going to ask for your forbearance and give you a little example of how this sort of thing works. I'm going to calculate the average age of everybody in the room without learning what any of your ages are. And the way I'm going to do it, except for Alan and me, we're going to be doing all the work here. The way I'm going to do it is I'm going to ask each of you to think of your age and split it randomly into two parts. So if your age was 60, you might split it into 20 and 40, or 25 and 35, or 5 and 55, however you like, randomly split it into two parts. So imagine you've all done that. I'm going to call the first part A and the second part B. So you've all got an A part of your age and a B part of your age. Now I want you to communicate the A parts to Alan and the B parts to me. Alan's going to add up all the A parts, I'm going to add up all the B parts, and then we're going to add the two sums together and then divide by the total number of people in the room, -2 because of Alan and me. That would give me the average age, but at no point would I have learnt, or anybody have learnt, the age of anybody in this room. Multi-party computation. So it is possible to do this kind of thing, to produce aggregate statistics without actually divulging any of the raw data. So I've been talking about various kinds of tools. For official statistics, Jonathan talked about new kinds of data. And I think this is one of the most exciting developments that's going to happen over the next few years. Surveys he referred to as the traditional way of capturing data, and that's absolutely right. But as he said, we've also got web scrape data, scanner data from supermarkets now, mobile phone data, all sorts of data sets which are going to be immensely valuable. And the point about these new kinds of data sets is that they have new kinds of properties which are different from and complementary to the traditional survey sort of data. And the obvious example that people normally pick on is timeliness. I can get details of credit card transactions, supermarket transactions as they happen, or at least within a matter of seconds or minutes, whatever, after they've happened. Whereas compared with a survey, it might take months before you find these sorts of things out. And then, of course, likewise, well, I should add, there's also data from commercial organizations. I want to make a brief distinction because I think this is important and opens up a lot of opportunities for understanding society. I want to make a distinction between observational and experimental data. Practically all of the data I've been talking about so far is observational. It's just things that happen and you measure it as happened. You're not intervening in it. It's not like a clinical trial where you're intervening. You're giving someone a treatment and seeing what happens. It's just automatically happening. It's just observational. That has a singular weakness when you're trying to understand public policy, or whether if you did this, would people pay more tax, or if you did that, would they be healthier? Because you don't know what other things might have caused those effects. What you'd need to do somehow is break a causal link. And that brings me to randomized controlled trials, which have been used in medicine since, well, you can go back as far as you like, but there was a very important one in 1948, which was carried out, and since then they sort of really took off, and they're just used all over the place in medicine. But they are also increasingly used in society. There's a rather nice book by, I think it's Richard Lee, I may be wrong with his first name, called Randomistas, and I recommend you look at that because he talks about the use of randomized controlled trials in society. But you can use randomized controlled trials in a variety of ways. One sort of begins to automatically think there are sort of ethical, moral problems about giving people treatment A, withholding the treatment from them, and those sorts of things. But on the other hand, if you're a little creative, you can get around these sorts of problems. Suppose, well, let me give you the example. I've got an example here of a road hardening experiment carried out in the city of Acayucan in Mexico. So they wanted to find out if hardening roads, putting tarmac on roads, helped the economy in some way of the city. And the way this city worked is at the centre of the city had hardened roads, but there was a sort of ring around it which still had dirt roads, and they wanted to gradually increase the amount of hardened roads, and they wanted to test whether it actually did any good. They didn't have enough money to do the whole lot. They could only start with some. So what they did was they randomly chose some of the roads to harden in the first instance, and they compared how that boosted the local economy with the ones which weren't hardened. So they not only were gradually hardening all the roads, but they were actually showing whether there was a point to it, whether it actually worked, whether it actually improved things. Okay, I've talked about tools, I've talked about data. I want to touch on something which is becoming increasingly important, and certainly in the UK we've seen a number of organisations which have sprung up to look after this, to control it, monitor it, investigate it, and this is data ethics. This is essentially the question of what are the right, legitimate and proper ways to use data. It involves, I'm not going to go into this in detail, it involves things like privacy, confidentiality and trust. And certainly in the UK there's been, and in Europe in general, a lot of data legislation and laws associated with it, the General Data Protection Regulation, the Digital Economy Act and so on. Didn't quite there are various, if you look at ethical frameworks, there are various... Sorry? Oh, it didn't... Yeah. There are various ethical principles. I've got I'll just list a few here. One is that they must have data analysis, data processing, data collection must have clear public benefit. Another is that the data collected have to be proportionate to need. Well, that's quite an interesting one because since it's now so easy to capture data and store it, the tendency in the old days you used to think, well, this is going to take a lot of effort to collect this data, so do I really need it? Things have sort of switched to the other side where you just measure it and record it. Sorry, is that? Yeah. Exactly, you just measure it and record it because you can. That might not be appropriate. So use data, collect data that are proportionate to need. Another one is to understand the limitations of the data. I'm going to say a little bit about data quality in a moment. And then the fourth one I've listed here, although there are others, is that analysis and processing should be transparent and accountable. It shouldn't be opaque and concealed. That's opening up a whole whole new thing. We can talk about that afterwards. Yes, yeah. So data quality. I just want to say a little bit about this because I think Jonathan mentioned this is a particular interest of mine. You sometimes hear the sort of assertion that we don't have to worry too much about data quality now because we've got lots of it. We've got billions of credit card transactions, for instance. We've got so much of it that, you know, if there's something wrong with bits of it, it will be diluted away, washed away. But that's not true. The painful fact is that big data, these massive data sets, have all of the problems of small data and extra problems of their own. So one shouldn't be misled by the sheer size of a data set doesn't mean that it's necessarily any good. There are various other aspects to quality. One is that it's not absolute. Data aren't of their own, in their own right, of good or bad. It depends what you're using it for. It might be perfectly adequate for one use, but not for another. And of course, different sorts of data have different quality properties. I was talking about timeliness earlier. If getting the information on time to do something is a measure of quality, then quite clearly some data sets are more useful, have a higher quality than others. Can't read my writing now. Yes, sometimes you hear the expression that data are the new oil. And one of the reasons for that is one of the sort of, you know, it is that like oil, data need to be refined before they can be used. You need to check for missing values, sort out distortions, check its quality and so on. But I would like to associate that phrase data are the new oil with some caution, because data differ in very important ways from oil. We shouldn't be too enthusiastic about that. For example, you can sell data and keep it. You can't do that with oil. Different people find a given data set valuable in different ways for different purposes, whereas people just burn oil. You can use data more than once. You can't use oil more than once, and so on. So there are, you know, one shouldn't be carried away with a simple little analogy. So where have we got to? I'm going to conclude by saying just a few things about the future. The future, and I think I may have said this 3 years ago or whenever it was, sometimes people describe what's going on in data technology as if we're just, all we've got to do is to get to grips with what's going on, develop an understanding, collect these vast data sets and understand and learn how to process them, and we will have reached a new plateau, a new normal. That isn't the case at all. We're, if you like, on the slopes of a mountain. And once we've climbed up a bit, by understanding the technologies, by building these data sets, we'll find that the top is just as far away as before. There will be new changes. The next 5 years are going to show us changes at least as significant as the last 5 years, for instance. And I'll just give you some words which will drive home why that's the case. Blockchain, we're familiar with that, but it hasn't really manifested itself perhaps in Bitcoin and other cryptocurrencies, but we're going to see it. People are investigating its use in many ways. One is verifying data sources. Now, that's quite an interesting possible use. Exactly. Personally, I'm dubious about the merits of cryptocurrencies, but I'm enthusiastic about the potential of blockchain in other applications. Encryption, of course, we all use at the moment, but we're going to see new developments in that area for security. Homomorphic computation. This is another of these relatively recent ideas. Actually, it was originally described in the 1970s, but it wasn't till the 1990s that people actually started to do it in practice as computer technology advanced. Homomorphic computation is very clever. Basically, you encrypt your raw data, and then you're able to send send it to somebody to analyze. They can't read the data, they just read the encrypted version. They process it, send the processed encrypted values back. They don't know what they mean, but you can decrypt that result. So very clever, some very sophisticated ideas. And then of course there's quantum sorry, yeah.
What is it called?
It's homomorphic computation. Yeah.
Why is it called homomorphic?
Homomorphisms are mappings which preserve structure. So. And then finally there's quantum computation, which we've all heard of, but is still very much at the embryo stage. So I'd like to finish by saying that all advanced technologies, This is the Partnership for Technology Management. All advanced technologies are fundamentally amoral. They're not unqualifiedly good or bad. And you've just got to think nuclear or biotechnology to realise that they can be used for good or bad. They've got immense potential for benefiting humanity, but also for damaging humanity. Indeed, in some cases, for ending humanity. And I would assert, forgetting a bit about ending humanity, the same is true of data technology. It can be used for the good or bad. It's got to be used with care and wisely. And on a sort of optimistic note, I'd say that when it is used with care and wisely, it can in fact open up a new dawn for the human race. Thank you.
Very, very well.
Thank you very much.
Yeah.
Questions?
Some comments. Let's go from there. Yeah. Because these are overall generic issues, not just about the crypto.
No, thank you very much. I thought this was really summarizing the whole thing so nicely, particularly reminding us that there's no way we can avoid the new technology that is coming into place, and that the technology has a role to play, but it's a question of how we use it, how we accept it. I thought that was very critical. The other one that sometimes touches on, Mihaela, the issue of disruptive technology is when this technology comes, how does it impact on the people? It will replace another technology that is existing. It will probably make another technology perform even better. But at the end of the day, how does it actually affect us as people? I think that becomes very important, the way I look at it. And the subject matter as well is, as much as there's so much big data out there, how do you access it? How do you also deal with the issue of privacy? It's so critical to when you have the data, there's so much you can use to analyze it, better communicate your findings, but maybe even your ultimately your decisions that you will make will be better informed. It's a question of how much you respect the privacy. Some of the data is collected from us without us knowing that that data is being collected. Maybe there's nothing you can do about it, but it is actually happening out there. I just wanted to appreciate this.
I think your point about how will this impact us, will we benefit, won't we benefit, is absolutely spot on. I wish I'd thought to say that, yes.
Yeah. So thank you very much for that talk. It is really enlightening. I just want to find out, because I'm not a statistician, so maybe I missed some of these things. But the whole afternoon, I'm hearing about collecting the data, analyzing the data, visualizing the data. But is the issue of storage not an issue? Because I've not heard about it. I mean, you're collecting, I'm thinking a CCTV. How many thousands of people does it collect information on a daily basis? How do you, I mean, I know there's cloud computing, but how do you store that data in such a way that 10 years from now, it's still available and they can be accessed? So the issues of storage, how important are they for these kinds of data?
I think in practical terms they're not important now. Basically, hardware technology, other people more expert in this area may disagree, you will more expert. But I feel that they are not a practical problem now. Computer memory is so cheap now that the data collected now will be available in 10 years. It's just there forever, sort of thing. And in any case, again, hardware technology is not standing still. New types of computer memory are being developed all the time. So I think the memory problem, the storage capacity problem, has gone away.
Just wanted to add one thing about the memory storage issue. Oh, sorry. I just wanted to add one more thing about the memory storage issue, is that, as David's mentioned, it's not really a problem anymore, but it is a problem in very certain aspects, but such as with Manchester University being a part of the square kilometre array, which will be built or is being built at the moment, that will generate data at such an extreme rate, they don't know how to store that data, and they haven't even built it yet. But that's just because it's going to be such an extreme amount of data. But for areas like fintech and things like that, it's not a problem.
Just a small question. You see, listening to your conclusion, I'm getting a little bit frightened on this technology, which can be used to the benefit of humanity. On the other hand, it can be very destructive to the existence of humanity. Now, what I'm missing is that is almost throughout the discussions when you talk about new technology development and all the others that go together with that. I'm missing answers, because I believe that all of us would like to use it to the development, or positive development of humanity. I'm not getting answers. How do we identify those areas that can protect us from? So that is what I'm missing. Thank you.
I think the answers lie in the ethical frameworks and the ethical organisations. The UK has just set up, the government has just set up a Centre for Data Ethics and Innovation. The Nuffield Foundation has set up a Centre for Data Ethics. These sorts of things are springing up. I can't speak for other countries, but I imagine it's the same. They're springing up all over the place to monitor, to keep an eye on exactly these sorts of issues. I think that's the answer.
Yes, I wish to join the other previous speakers to extend my gratitude and appreciation for the way you presented the information. It is very clear and very informative. But as you rightly say, there is a downside. Technology can do anything now. It has brought a lot of innovations that can help mankind. But there is also the downside, especially what we call now the fake news or fake information. Now, are there any prospects? Why is it that it cannot be controlled? Are there any prospects that it can be controlled? I hear the European Union is trying to do something. So what is the state of the affair now? Is there any prospect?
A very, very good question. And a bit like the answer to this question, because it's become so important, thanks to Donald Trump, everybody's heard of it, people are beginning to look at it. In fact, I've just written a little paper where I say I think one of the answers is data provenance. I suggest that everybody reporting a fact or a number or a statistical data should say in a footnote where they got it from, so that you can actually follow it back and follow it back through the chain to where it actually came from. And if they don't give the provenance, the genesis, the origin of the data, you should draw your own conclusions about the veracity of it, how true it's likely to be. This isn't the complete answer, but I think it would be a step forward. But more generally, because it's such a hot topic at the moment, people are beginning to look at it and try to find ways to assure themselves that the news is real. Yeah.
Comment on two things. In the issue of the fake news, basically fake news are just like crypto to fiat currency. Now, the area where a lot of research is done now is into sentiment analysis, designing algorithms that they can discover if this such kind of news is legitimate or is not, or is coming from the sources which are not correct. But that area is still new. So there are a lot of attempts which are done. For example, Facebook, they say they're improving their algorithm so that their platform will never be the platform for fake news. So that's the comment number one. Comment number two is on data centers. Based on my experience with data center we have in Tanzania, it is true that there are a lot of information which are produced nowadays, but acquisition of equipment is not a big problem now because the price of equipment are going down. Issue is into electricity and cooling. So the cost of those two components, they are going up as time goes. And the complexity of the matter is sources of electricity, they are still the same. And perhaps later on, maybe countries will start to go to another means of producing electricity for that. And that's the reason why yesterday we were saying there are countries, based on geographical position, they have advantage in providing such a kind of services. For example, they have temperature that make the cost of cooling going down, like Lesotho, Iceland, the way it is now. And I think Russia, they're using exclusive Siberia for their own use. Yeah, so those are my two comments on that.
David, I want to ask you a simple personal question, as somebody once asked me whether I believe what I read in newspapers. Do you believe what you read on Facebook?
I don't belong to Facebook. You can draw your own.
But this is the greatest danger, I think, to the human race, is that the fake news has completely undermined information, which is actually a fundamental tool for human organization and evolution. So we're in danger of losing information, rather like these big animals which become extinct. I think that's the biggest danger. You won't believe anything, and then what do you believe, what don't you believe? Yeah?
I think that's very true. But on the other hand, I think we are now witnessing a backlash against these big organizations and the consequences of them. So, you know, if in my more optimistic days, I have hope for the future because of this backlash. So.
Alan, did you know there is a BBC here?
You didn't tell me before.
You are so much part of us.
And it's one of these stamps that it's quite difficult to get rid of. It's a bit like having been in a concentration camp, you know, you can't get away from it. But I was in the World Service mainly, so that's a very healthy bit of it. I just wanted to say, first of all, to say how brilliant the contributions from sort of that area of the table were and what has been said. And that's been sort of the fun bit. But going back to what was discussed by the governors this morning, and the point was made by a colleague from Cameroon about what do we take away. You know, there are things that we don't care about. There are things that we say, that's fun. And then there are things that we say we're frightened of, and where do we get the security? And there was a presentation from Malta this morning where they were talking about the legislation they were putting in place in relation to blockchain and other such things, you know. And they were saying that there were three possibilities. Don't regulate, regulate with a strong voluntary element, and regulate with compulsion. And obviously all countries are considering these matters now, whether in regard to Facebook, identity fraud, hacking, whatever. And many of the biggest dangers come from some of the big states, not to name any. And I just wondered what your thoughts were on that, and how we have it in the Smart Partnership movement, the phrase moving forward. And I was just wondering, without being didactic, whether there are things we could say as a result of the expertise that's been gathered here about where we must regulate in the future to protect individuals and society.
Some regulation certainly is necessary. I think, as I think was mentioned from here a moment ago, that we can't opt out. These things are happening. So we have to engage with them. If we don't, then everything is at risk. So I think some regulation is necessary. I have to think about the extent of it to answer your question.
I think regulation is obviously something that we've got to consider very, very strongly. But the reverse of that as well is that with fake news, how well primed are citizens to deal with it, right? Like there's an education element here that is the only way of guaranteeing that someone's going to be able to be exposed to fake news and detect it and filter it out, there is a responsibility. So the citizenship skills that come along with the technology transformations that we're seeing, for me, is the big issue, because we're moving now, the change is moving at such a rapid rate that if you're teaching at university, how on earth are you preparing a generation of people when you don't know what the world's going to look like in 5 years' time or 10 years' time? So the underlying, how do I learn to be a citizen that's going to be a citizen in 10, 20, 30 years' time is incredibly important. That goes back to the literacy, numeracy, data literacy, graphicacy, all of those things are incredibly important.
I think that's exactly right. It's all very well asking people to check whether a particular piece of news is right, but if they don't think to do that in the first place, if they're not skeptical, if they don't ask themselves, yeah, is that really true? It's a waste of time. You've got to encourage that sort of attitude.
Sorry, actually, that's really interesting, because I think what we've heard is a lot of sort of Bitcoin's bad, cryptocurrency's bad. But now we're talking about fake news, and there's a couple of interesting companies that have started up out there that are actually having bounties for fake news. So if you find a fake news, you'll be paid in a cryptocurrency. So this is a So there's cases where really, like, the one thing I think the gentleman this morning said we have to take the blockchain away from the Bitcoin. I don't think that's right, because of the reason why we're all talking about blockchain is because of this guy created Bitcoin and or lady or group, and basically they gave us an idea that we could transmit value peer-to-peer wise, a value of storage, a bit of knowledge, and we could cut out the middlemen, so thereby reduce the cost of trust. And I think the gentleman from Cameroon said, what are the prospects here? And then if you put all of the data, analytics, statistics together, I mean, the gentlemen, central bank governors in the room can all have real-time knowledge of where all of their commodities are, where they're going and who they're going to. And this is really something for the future, because this goes back to the roots of the agriculture, all of the mining we do, trade and finance. So and all of these technologies mesh actually quite well to create very positive solutions for the future. Sorry. Got to be.
All right. Maybe I can add a bit. In Malaysia, before the elections that happened last month, the few months preceding that, there were a lot of news that was spread around, mostly on social media, good and bad for both sides of the political divide. So much so that the government of the day at that point in time actually passed in Parliament Anti-Fake News Act. I'm not sure whether all of you are aware, but it was passed in Parliament within 1 day. So I'm not sure whether I've looked at the act myself, and I'm not sure whether it's, I don't think it's comprehensive, but maybe if any of you are interested, you can actually have a look at it. But it's actually law that is in practice in Malaysia right now. But looking forward, actually, I've just received, for example, on my WhatsApp message this morning, a message that I find it's normal to receive. There's a lot. It's actually continuation of we receive chain emails, news that nobody actually bothers to verify and just forward it to everyone they know. So there was one disturbing message, to me at least. So what I did was, it was an image, and they had some description on it, saying it's about religion or something like that. What I did was, I just did a Google reverse image search, and I found that the image is completely about something else, not related to what it is being peddled around on WhatsApp. So I think the main issue here is people need to be aware that they have to actually check the messages that they receive, the news that they receive, whether it's true or not. the best is actually by doing a simple Google search. Most of the time, most of the stories are hoaxes anyway, so you can actually verify. Okay, that's all. Thank you.
That's a very nice example of what I meant by provenance. Where did the data, in this case an image, come from? You had to go to the effort of a Google search. If you hadn't found it, you wouldn't know for sure. And I'm just saying that had they put at the bottom the website or the source, the paper, where they got it from, we could check that easily. So, yeah, a very nice example.
David, and thank you for entertaining this end of the whole day. And